to the Watt Hour, where we power the conversation around defense, aerospace, and next generation energy solutions. I'm your host, William Hadala, and today we're diving into the real world challenges and opportunities surrounding forward deployed UAVs systems, with the special focus on power, logistics, and thermal solutions required to operate close to the fight tonight. Joining me is Eugene Jansen, a leader in thermal and fluid engineering whose work at TFSG has helped shape critical systems deployed at the edge of tomorrow's battlefield. Eugene, welcome to the show.
Thank you, William, and thank you for having me. I appreciate it.
Yeah, we've known each other for some time, so I'm excited about this interview. So let's begin what we're seeing in real time, the Ukraine conflict. UAVs have become more than surveillance tools. They're precision strike weapons, ISR platforms, and even decoys. Just last month, drones struck deep into Russian aerospace, reportedly destroying nuclear-capable bombers. So my question to you is, from an engineering and logistics lens, what does this evolution of drone warfare tell us about the power, cooling, and deployment infrastructure needed for the modern battlefield?
Yeah, absolutely. So I think there's several different facets. I think one of those facets is energy density and the ability to rapidly charge and discharge batteries. And I think the solution there is simple. Buy ALE batteries. I don't give out those sort of recommendations willy-nilly. I have had the opportunity to test ALE's batteries and work closely with you guys. See that data not just from you guys, but from our own testing, and correlate that and verify things like your 400 watt hour per kilogram batteries. And so that is a critical enabling technology, and it's awesome to be able to work with ALE in that, bringing that to the warfighter and in this domain. Another aspect, though, is energy requires power, and how do you deliver that power close to the fight, right? How do you get generators and other battery systems or energy storage there to provide the energy to those drone platforms? How do you get that as close as humanly possible to the fight? And you had Lieutenant Colonel Rossi on a couple of weeks ago, and he provided one of my favorite quotes, that amateurs talk tactics and professionals talk logistics, right? So how you get the power there, how you get the drones, deliver the drones to the battlefield, as well as that power and that capability, matters more than what tactics are enabled by the drone itself. If you can't get it there, it really doesn't matter. So I think that kind of rounds out the question, William. What are some of your thoughts?
Yeah, it's really the logistics and how do we strategically insert this energy into the tactical edge, and doing it in a way that the more sensors and the more platforms that we deploy across land, sea, air, and even into space is going to be more data than we're accustomed to dealing with. And as you know, with the Global Hawk program a number of years ago, we had challenges called the big data bottleneck latency. How do I take all this data, ingest it, process it without having to ship it back to Langley, while at the same time having to address the data issue also has to address the power issue? How are we going to get power into the field to deal with the processing? So it's no longer about launching from a continent away. We need UAVs that are capable of forward deployment, need systems for the modern warfighter, from the warfighter, the squad, the platoon, and so on. So back to you, what are some of the key thermal and power challenges in setting up forward deployed UAV systems, especially when operating in extreme environments or with limited logistical support?
Yeah, absolutely. So a lot of these systems are heavy and big, right? So being able to get those forward deployed is an issue. With the current capabilities and legacy systems, we simply cannot get those assets close enough to the fight, right? So it is going to take a new solution that is not just future-proof, but is also legacy compatible, right? And this solution that we're developing at TFSG does that. So it is producing that power. Now, anytime you produce or use power, that creates an incredible amount of thermal, right? And that's what we've done for a long period of time, thermal and fluids management. We work very closely in the directed energy domain, one of the most difficult and taxing domains from an energy density perspective, as well as power perspective. So we work very closely, power and thermal. And over the years, I've delved more into the power and more recently less into the thermal, but they are interrelated. Ultimately on directed energy platforms, whether it's high power microwave or it's high energy laser, it is your power and thermal management systems that are the limiting factors. It is not, in fact, the laser system or the high power microwave device. So the power and thermal and how you deliver that combined package to the battlefields is a logistics, again, discriminating factor, not just for drone systems and directed energy, but as you started to mention there, edge compute at the edge of the battlefield, having that capacity closer to the fight, so you're not having to transmit as much data, which is a vulnerability, right? And then other reasons to have power at the unit level, at the lowest level possible. Take that hub and spoke design for fighting battles and expand that. More hubs, more spokes, right? Get it closer, get it closer, get it closer. Be able to reach out and touch that bad guy within hours and minutes instead of days.
So you can argue that Ukraine is an inflection point in military doctrine, much like the Reaper UAV changed warfare after 9/11. And today's drones are smaller, faster, and more deployable, and are shifting how we think about combat readiness. So how do you see modular thermal power systems adapting to this new reality where flexibility, speed, and interoperability are essential?
Yeah, absolutely. And thank you for bringing up the Reaper and kind of the post 9/11 era. I'd like to think if we saw the Reaper today, right? If we saw the new generation of what that is for the next battle, we'd know it, right? But I'm a little concerned that maybe we don't. We've already seen with Ukraine how effective drones can be, and these small FPV drones, attaching some ordnance to those drones and them becoming precision munitions, attritable platforms, and very low cost, right? But are we adapting fast enough, right? Or are we still going through that typical, evolution of big R requirements, with congressional ties to program funding, right? So you've got that three years for big R requirements, you've got 3 years for program funding to get aligned, and then you've got at least 2 years before you deliver anything, even low rate initial production, to the warfighter for even experimentation. Can we really afford an entire decade of development for solutions that folks are developing overnight in domains like Ukraine, right? So both on the Ukrainian side and the Russian side, right? Out of necessity, necessity being the mother of invention. These folks are having to do this. They're living this real time. Are we really moving at that pace? Are we adapting how we're developing these solutions and being able to deliver these solutions for our warfighter to make sure that they come home?
Yeah,
So
one of the oh god, Nika.
another thing you mentioned, William, was the Reaper, and again, I think that's really interesting to take the approach of, what would that look like, the modern day Reaper, and how did that development go, right? So instead of taking the traditional development cycle of 10 years, looking at the Reaper, prior to the Reaper was the Predator. In the 90s, developed in conjunction with General Atomics and the U.S. Air Force. They developed that critical ISR platform. It could carry 2 Hellfire missiles, but wasn't really a discriminator in that domain. But then General Atomics said, "Hey, look what we did with that. We can do a Reaper. It's a larger, albeit heavier, but a faster platform, a lot more lethal. Can carry 4 Hellfire missiles. Can carry 2 GBU-12s, and it just provides that much more of a discriminating factor in the battle, right? And the Air Force was on again, off again, on again, off again, until they were off again. And this was 2001. They made that final decision. General Atomics was set to shut that program down. And the entire technical team, all the way up to the fellows, pushed back against management. They said, "Hey, this isn't right. We know the warfighter needs this capability. We really need to develop this in-house." And so early 2001, that's exactly what they did. And sure enough, September 11th, hits, and they could not produce that platform fast enough, right? They could not field it fast enough. So it took them taking on private dollars and taking on that expense and going ahead and developing it without any of the red tape, right, for it to then be fielded and usable. And a lot of folks don't know, but that platform didn't receive proper EQT or proper qualification testing until several years later. In fact, some tests were never done. Some waivers and deviations exist to this day. Cyber was another one we saw in the news where Iran had downed a couple of those drones because, again, they were not properly qualified or properly certified, right? But that really is what it's going to take, is that sort of a mentality. Like, we know this is right. We've got to go do it. We've got to deliver it. And we know the warfighter will need it for the next battle.
So if you take a look back to what you're saying, the Reaper wasn't originally designed as a strike platform, post, 9/11, it quickly evolved with new sensors and weapons and mission profiles. From your perspective, how did the lessons from the Reaper post 9/11 acceleration inform what we need today in terms of thermal management, cooling, and scalable deployable infrastructure for a UAV system?
Yeah, so I think that hub and spoke system and being able to deploy even program or platforms of that size faster, right, more rapidly, how do we get that closer to fight so that when it takes off, it is a loitering platform. It does have roughly 24 hours. It can be on point in air, but there is a distance to target, right, and that starts to impact how long you can stay on target. So the closer we can get to the battlefield, which is what we intend to do, right, get those platforms closer, whether it's group 1, 2, 3, UASs, get those platforms closer and closer to the battlefield so that they can be more effective. I think ultimately the loitering technology is starting to hit a knee in the curve, right? So there is more development going on there. Obviously battery systems will help in limited capacity there, but you're still operating on gas turbines with diesel, which got incredible energy storage capacity, but that is a known quantity, right? So kind of limited with how far we can go there. It's a function of being able to get that platform closer and closer and closer to the.
It's one of the things that I've been sharing with the teams at the operational energy as well as across various commands are when it comes to group 1, 2, and 3 drones, you have amazing OEMs that are building products for the modern day warfighter. And as they're scrambling to figure out where they're going to get their batteries from for many different reasons, which, we don't have to necessarily, talk about on this episode, they're building batteries for platforms that are going to be platforms in 3 years that are obsolete. And that's what Moneyball military is all about. No longer having these big money programs, but how do we put money into commercially off the shelf available consumer electronics that we can put into the fight, like we've been seeing in the Ukraine, where they're just making anything work. So why are we building batteries and standardizing as an industry when perhaps we should be standardizing on the batteries to build the platforms around? So that's one of the things that we see as a
I totally
challenge.
agree, William. And again, in this domain, I don't know why for a DoD platform you would go with anyone other than ALE once you see the data. But fundamentally, you're absolutely right. We're seeing a lot of different folks develop essentially the same hardware. Now, there's going to be winners and losers, but I think ultimately, if the DoD is buying tens of thousands of any particular platform, by the time it gets to this field, it is going to be not useless, but much less than the use that it was designed for, right? I think the smarter move, and you're seeing this to some extent, is how do we rapidly deploy manufacturing capability for the very latest technology in the event it's needed, right? So, why are we building tens of thousands of a drone that is going to be 10 years old by the time it's actually in the fight? Why aren't we standardizing how we manufacture these things? And to your point, standardizing the battery systems that are meant to be used in these things. we know, but not a lot of folks know that there's a battery pack, and inside the pack, there's assemblies of modules. There's individual cells, right? But those components make up that total battery pack. If you can modularize those cells, those groupings of cells, or the modules, or the assemblies of modules, if you can modularize that and standardize that, then you're not reinventing the wheel with the most critical aspects of environmental qualification testing and certification of those modules, what really matters when you're going to deploy these assets. So I totally agree. Energy is important, and using the very latest is great, but you need something that's qualified, something that's certified, something that's not going to go into thermal runaway, even though it's the next best thing that somebody wants to deploy.
Right. And that's where ALE 0 technology, being able to take the battery to 0 volts, and now even into negative
Absolutely.
0 volts, now actually for 10, 20, maybe 30 years as a reserve. And then SafeCore, preventing the three most common reasons why cells go into thermal runaway, which, as you know, are internal shorts, overcharging them, and then temperature. But most importantly, standardize on the battery packs with the cells, modular, swappable energy, as well as power side by side. And I can pull it off like a BB2590 and put it onto a drone or put it onto a trailer.
Absolutely.
So that goes to the one challenge we constantly hear: how to future proof. And you just said it, systems. And as the battlefield evolves, so our infrastructure must be sustainable, modular, and compatible with legacy and future tech. So how do we approach designing for interoperability, both in terms of heat rejection systems and then power architectures, so they don't become obsolete in a few years?
Yeah, absolutely. So historically, battery cooling has been done or largely ignored, but through conduction and then ultimately convection to air. We are seeing more and more, with Tesla as the perhaps biggest example in a mobile platform, where liquid cooling is being used, direct single phase. But you will eventually see, when the heat fluxes are high enough, you will eventually see two-phase cooling as well, even on mobile platforms, but especially in high rate discharge areas as the power capacity of these cells gets higher and higher and higher. But fundamentally, I think for the next roughly 20 years, we really should be designing around a liquid-cooled system, a single-phase liquid-cooled system. So like a propylene glycol water mix or an ethylene glycol water mix, whatever is standardized in the military already and widely available. I think that is fundamentally what we should be doing. I think that will encompass, not only those things that don't necessarily need liquid cooling, it will extend the life of them and enhance the capability for charging and discharging, but it accomplishes the requirements of even future platforms for the next couple of decades. I think liquid cooling is a must in a generally designed battery pack.
And I couldn't have invented this story. It's very serendipitous, all of this from my career, your career. I mean, coming from a two-phase, single-phase background and data to now battery storage. And here we're talking about that right now. And if you can have increased energy density and power and reducing the weight, using liquid cooling balances itself out, especially if there's rate requirements. But if we're building the platforms around the batteries, like we standardize in like World War II, AA, AAA, C, D, but only much larger, theoretically, we set the standards for the future batteries, regardless of their weight requirements, to build the platforms that can leverage them. So that then ties into drones. They require serious energy, not just for the fight, but for ground systems, recharging stations, cooling units, and command links. And I'm very fortunate to be part of the DARPA Power project, where we're wirelessly transmitting electricity for exactly what I'm about to ask you, is that how do you see hybrid power systems, battery tech, and perhaps even edge computing working together to support sustainable UAV ops at the tactical edge?
Yeah, absolutely. And this is something that hits home for directed energy as well. We don't typically have a level load, do we? We typically have a short period, a short duration where we're doing a lot of dispelling of energy. In the case of drones, it's the charging scenario. But in the case of directed energy, it's taking a shot, right? Whether it be high power microwave or high energy laser again. And so designing a system to do 100% of that power all the time, when it's only ever going to do that for a very small portion of time, that doesn't make a ton of sense. And so we curb that appetite of power by including energy density on whatever platform it is. So while the drones have their batteries, your platform for recharge may have its own set of batteries as well. And that curbs the appetite for that gas turbine or that diesel generator or that fuel cell in the future that may be providing that prime power, that prime mover, as we typically call it. Hard to call a fuel cell a prime mover, but effectively that's the place it takes.
So there's a growing recognition that forward deployed systems are a necessity, not a luxury, but logistics still lag behind the tech curve. So from a systems level perspective, what investments, whether by government or private equity, are needed to make forward UAV deployment infrastructure scalable and reliable?
Yeah, again, I think we've seen a few experimentation programs, but we haven't really seen those big R requirements. Again, I'm talking to the folks inside the Army, RICTO, SMDC, and other development programs, and they're all telling me the same thing. You need to talk to the folks at Fort Moore in the maneuvers and get them to write out those requirements, right? And then ultimately get them to align to congressionally mandated funding. And then, you hope for a program of record something like 5 to 7 years from now. In reality, again, that's just not going to meet the timeline. This is going to take private funding. This is going to take private equity. And the return equation is simple, right? If the government does not pay for that development, ultimately they will have to pay for, the cost of those platforms in the future. It's obvious to me, right? This is the future reaper of the next generation. And I think for those that can see it, it's a massive investment opportunity, right? The ability to forward deploy these assets as close to the fight as humanly possible. Lieutenant Colonel Rossi, again, he's a Marine. I think the Marines do this very, very well. I think they do this the best of all the military forces in the world. They have what are called MUs, Marine Expeditionary Units, and they pre-position ships that have all of the equipment necessary to support 2,200 Marines, right? The smallest unit of a MAGTF available. And they can deploy the Marines with that equipment between 7 and 10 days anywhere in the world, right? And that's incredible when you think about the logistics involved there. But that means it takes 7 to 10 days to get us on a field, and then who knows how long to actually reach out and touch, whoever it is. Now, if we pre-deploy these assets, a little bit more hub and spoke throughout the world nearer the bad guys or what we perceive to be the bad guys, that really enables a much faster action, right? Instead of reaching out and touching someone within days, it's hours, or as we see it eventually, minutes. And that's not taking a $50,000, $100,000, $250,000 missile asset to get that job done. Right, that is actually being nearer the fight. That is being able to also gain ISR capability nearer the fight. The enabling of these technologies goes beyond just being able to accomplish that first mission, but it's the next one, the next one.
Yeah, and as far as investment is concerned, I've always said that, and there's many in the military at leadership that will say a lot of times manufacturers of drones or batteries or whatever it may be, they have their hand out, their tin cup, hoping that the next military program will fund their development, and they often lose sight of the commercial side of the equation. And I come from the commercial side and had a mass scale. And when I think about UAVs and even directed energy, and in the sense of directed energy in the high power microwave, is that there's this thing coming called counter UAS. And counter UAS, for those that may not be aware of that, is what do you do when you have a drone flying in your backyard or over your stadium or even over your military base? So the military has ways of dealing with that. But because the laws in the US aren't written to counter a UAS, whether it be compromising its software to redirect it to land somewhere, or even perhaps taking it down in a way that doesn't cause any type of harm in the public, is that every law enforcement agency in the United States one day will need counter UAS, which is exactly what we're doing on a forward operating basis and on our ships, et cetera. So
That's right.
there's this tremendous opportunity for what we're talking about right now that all need ground-based segments anyways, with the high
Right.
capacity compute, with 6G satellite. So I'm just not sure if people are seeing that these OEMs, and we've got such a flashlight focusing in on the military applications that there's going to be an opportunity for those to shine the light on the local, state, and federal government. Would you not agree?
I totally agree. I think inside the military as well, some of these more complex pieces of hardware, high power microwave, high energy lasers, as a great example. We're taking these $25 million lasers and putting them on a $500,000 platform. Does that really make sense? Does it make more sense to maybe develop a platform for the future where we can share assets that are doing more than one duty, right? Why are we carrying batteries in a battlefield but not using them to get us there? Right? Those are the sorts of questions that we're asking and providing solutions, real solutions for that future fight. So I
So this is
totally
where
agree, William. Batteries are a massive part of that future solution. And again, I think ALE in this domain, defense, I don't think there's anyone better than ALE to provide those batteries.
No, if we can scale up this mega factory that we're building, this 82,000 square foot factory that I'm sitting in right now, and do it successfully with quality and yield, the question that I have to my leadership is, where are we going to put the next 10 gigawatt hour, 100 gigawatt
Right.
hour? And if Tesla has 60 gigawatt hour worth of battery production capability, and I have the ability to do 600 megawatt hour to 1 gigawatt hour, theoretically, that's 1% we're etching away from that. But I'm not looking to create fights. But this is where public and private sectors can collaborate, right? Imagine a turnkey solution where mobile UAV hubs, integrated thermal and power systems with modular deployment kits and edge computing can come in. So what role do you see the private sector in playing in accelerating this type of innovation, and what are the hurdles to getting these solutions adopted in operational environments? And from that perspective, think commercial as well, beyond just military and government.
Absolutely, absolutely. So private sector government, right? We call it private sector government, but really, your local governments, state governments, et cetera. The requirements for delivering those solutions, the environmental qualification as a big one, when it comes to shock and vibration, et cetera. We're not worried about bullets flying. We're not worried about missiles flying. EMI is less of a concern. uh, salt spray and humidity. There's a much lesser elements of those solutions, right? So that being a precursor to something that is ultimately in a military application, that kind of a dual use format makes a lot of sense. And then when you talk about more specifically private for, say, security of events, right? We've seen a lot of issues with large venue events and issues where drone surveillance would be beneficial, right? Being able to identify problems, well ahead of them being a massive issue. But those sorts of private applications then driving future development that's elevated in terms of environmental qualification and requirements. Not only is that an easier path and makes more sense, but you're not initially designing for end-to-end requirements. So you're able to field something, you're able to get it out in a lower cost form factor and really drive down the cost before you then try to apply it in those elevated domains. So I think they do really play together. I think the low-hanging fruit may be in the private sector in certain niche domains to help with that development and aid and provide some level of revenue and cost reduction elements to this equation along the way. But fundamentally, our fight is the DoD warfighter, making sure they have all the equipment they need, to do what they have to, provide a discriminating capability and make sure they get home. Ultimately, that's our MO. We want to get there. How we get there is not as critical to me as making sure that we get there as fast as possible.
Yeah, and from a commercialization perspective, especially in the commercial sector, infrastructure, platform as a service, this is all financeable, triple B graded or
Absolutely.
more, which I believe most cities are in utilities. I don't want to lose sight on the military and the warfighter needs, but also this is technology we need today now. So tell me about TFSG and what you're working on, and and what it is you all do. How can we help you?
Yeah, absolutely. So I am being particularly, coy about this whole solution. There is a lot of proprietary information that's wrapped up in it, and we are looking to file the necessary patents and move on this. But TFSG was initially established in 2016, pretty strictly thermal and fluid solutions for high energy laser platforms. I actually worked at Lockheed prior to establishing TFSG and worked in undersea systems and ocean thermal energy conversion, of all things. But that led to an opportunity to work in high energy laser thermal management inside of Lockheed. And then I was actually asked by Lockheed to step out and help one of their partners develop a power and thermal solution. And so that was about 2016. And that partner wasn't comfortable with me stepping away from Lockheed, learning everything they do in power and thermal, and then going back to Lockheed. And so I said, hey, I've got this crazy idea. I've always wanted to own a business. And they said, well, we'll go discuss it and come back to you. And they said, yeah, let's do it. Let's do it. And so I went to Lockheed and I said, hey, I'd love to help that partner of yours, but here's what we're going to have to make work. And to my surprise, they said, yeah, absolutely. Let's do it. So, a very unusual turn of events. I had the blessing of Lockheed, my former employer, to go help their partner with a solution. And so I exited, getting paid immediately, which is not very entrepreneurial. But, a year and a half later, I was done with that initial effort. And I decided to develop some intellectual property and actually prove it out in hardware. And then I sold that technology about 6 months later and invested everything back in the business, started expanding, and developed a custom 4,000 square foot facility for prototyping for high energy laser efforts, which we did amazingly well. We were experiencing exponential growth until about COVID. And then COVID hit us especially hard. We lost about 85% of our revenue overnight. And ultimately, my staff ended up trickling down over the next couple of years. I stepped away into private industry, which is where I met ALE. I met yourself, William, as well as Danny and Dr. Fan. Fantastic leadership at ALE. And then I decided to restart TFSG about a year ago and look for that next application, something beyond strictly high energy laser, but instead of repeating the same development programs for directed energy, et cetera, how do I enable these technologies to actually get to the battlefield, right? What is the way we make all this work, not just now, but in the future? And that's where I'm at now.
That's awesome. So, we're at the crossroads of innovation and urgencies, and system like TFSGs are quietly doing the hard work to ensure we don't, just build drones and directed energy and et cetera, but deploy them smartly, sustainably, and safely. What gives you the most hope right now in this space, and what keeps you up at night?
I think what both gives me most hope and keeps me up at night, it gives me hope that we've had that, unfortunately, it's not a 9/11 moment, but we're seeing what's happening in Ukraine, right? So there is a wake up call, right? It's out there, right? So that gives me hope. I think other people are seeing it as well. I don't think everyone is seeing it in the necessity. I think it's still a little bit too far from home. But those of us that see it and understand the importance and the relevance, we get it. What keeps me up at night is the other folks that do not, right? The other folks that do not see the importance and the relevance, and that it seems far away, but this battle can come to us very rapidly, right? In a Connex container. That's what keeps me up at night, right? So developing solutions and getting ahead of it, and being ready for that battle, being ready to fight it for when it comes, and not on a 10-year cycle.
Yeah. So, Eugene, thank you for joining us today on the Watt Hour. And for the listeners who want to learn more about TFSG or dive deeper into this topic, we'll include links in the episode description. So, until next time, keep innovating, pushing forward, and staying powered. So, thank you so much for your time today.
Thank you, Wayne. I appreciate it. Thanks for having me.
You're welcome, sir. Take care.